in polar form, I need to put them into rectangular form. Similar to what we just did, except the reverse. So I've got this vector, magnitude 300 meters, angle of 37 degrees. I'm going to establish I hat, j hat. They are perpendicular to each other. Please don't come up with unit vectors that are not perpendicular to each other. That is a much more advanced topic. So I have this angle here. I have some side here. I'm just going to label little a and little b. And I need to figure out what little a and little b are. Well, I have the hypotenuse. So using sine or cosine makes sense because those have, sine has a hypotenuse in it. So the sine of 37 degrees is equal to the opposite over the hypotenuse. Or b is equal to the hypotenuse times the sine of 37 degrees. Somewhere around 180.
But what are the numbers around the line? I can't see from the marker this way.
Oh, this is 300 meters. And that's 37 degrees. And those are just dotted lines.
What is the one right by your hip? Not the A or the B, but no. The one to your, yes, that one. What's that on the other side?
What's that? That's 90 degrees. Yep.
How did you put the sign of a degree in the calculator?
So make first, in a calculator, first make sure that you're in degrees. If you're in radians and don't know how to get it out of radians, then you would, so to convert degrees to radians, you would multiply by pi over 180 degrees. That'll get you into radians if you have to go that route. But if you're in degrees, then you would just type, my calculator, you would type 37 sine 300 times on the TI 80 whatever, I guess you do 300 times sine 37 equals.
Does that say 37 degrees down there?
That's 37 degrees there, here.
Yeah, right there.
Yep, that's 37 degrees.
The 90 degrees over there, were you saying that was for like the y-axis or?
Yeah.
Okay.
Yeah, just going with it, 0 degrees, 90 degrees, this is what the math people have come up
Okay.
with. Actually, it's what the Babylonians came up with, but we seem to be stuck with it. So what do we get? Say it again?
180.5.
180.5. And A, because it's the adjacent, the cosine of 37 degrees would be A divided by 300. Or A is just 300 meters times the cosine of 37 degrees, probably little a. And it should come out to, I'm going to guess, 239.5. What is it?
239.
So this first vector here in rectangular form is 239.6 meters I hat, because I said I hat is to the right, plus 180.5 meters j hat, plus, now let's do the same for this, except we're gonna do it slightly faster. We can go through the exact same argument we did right there, except it's gonna be 400 meters times the cosine of 127 degrees I hat plus 400 meters times the sine of 127 degrees j hat. Now, you could go through, there's a longer process you can go through, but ultimately it comes down to if I hat and j hat are defined in the traditional ways, then it's the hypotenuse or magnitude times the cosine of the angle I hat plus magnitude times sine of angle j hat. So this will be I just have a lot of faith in you, Daniel.
-240.7.
Is this one?
Yeah.
Negative 240.7?
Yes.
All right. Now that they're both in rectangular form, adding them is trivial. So we have negative 240.7 meters I hat plus 319.5 meters j hat. Now you add like terms. I have I hat here and I hat here. We do have some rounding issues there, but given the numbers that we have. Let's see, so that's negative 1.1. And then we add the j hat components, and we get 500. And there's our answer. Or I could also write it as negative 1.1 I hat plus 500 meters j hat, so 500 j hat. I can't forget units. The whole thing in parentheses, just put meters outside. If I don't put the parentheses in that second form, then all I've done is add meters to the second term, not the first term. Questions? I believe there's someone impatiently waiting. We're not, don't get out of here, she's gonna send her goons in, and then there's a physics fight. And those aren't pretty.
Thank you, Dr. Russell. Not first, which would be
Okay.
I think thank you.
That was an example, this is the kind of thing that,
Well, I get the like, this part is just, I remember that from the trip. But when I looked at the homework, I was like,
I'm walking away, it sounded like you know how to do,